Hello everyone, welcome back to our game development series where we're building our very own RPG game. This is the part 1 on creating our targeting system. This is a complex task which will take us into 2 videos. Now, let's not waste any more time and get right into it. To get started, we'll need to create 2 new scripts, Target and TargetManager. Next up, we're going to add a new empty object to the player prefab. You're free to name it whatever you like, but for the purpose of this tutorial, we'll be calling it TargetManager. Once we have that, we're going to attach a new sphere collider component to it. Now, the size of this sphere collider is flexible and you can adjust it based on how large you want your player target range to be. For detecting purposes, we're going to make sure that this trigger option on the sphere collider is checked. This way, it only detects overlaps instead of physical collisions. Here's something crucial. In order to ensure that our trigger events are properly sent, we also need to add a rigid body component to our target manager. Just remember this note. Trigger events only get dispatched if one of the colliders involved has a rigid body attached. So, we're ticking off another key requirement. For our rigid body, we're going to make a couple of tweaks in its properties. First, let's untick the use gravity option as we don't want our target manager to be affected by gravity. Then, we'll check the is kinematic option, which will prevent the rigid body from reacting to physics, while still allowing it to interact with other colliders in the scene. And that's it for this section. We now have a functioning target manager ready for action. Now that we've set up all the necessary components, it's time to dive into scripting our target manager. The main idea here is that any game object with a target component that collides with our player's sphere collider can be flagged as a potential target. To keep track of these potential targets, let's start by creating a list where we can store them. You can initialize this list with public list target called targets equals new list target. With our list ready, we'll then create 2 helper functions, add target and remove target. These functions, as their name suggests, will add targets to and remove targets from our list. So let's implement first the add target method. It will be public of return type void named add target, and it will take in a target so we can add it to the list. Then we can just simply call target.addTarget. Now let's move on and implement the remove target. Public void remove target takes in also a target, and we can remove any component by simply calling targets.removeTarget. Having this function in place, we can now start utilizing the onTriggerEnter and onTriggerExit methods. These methods, available in Unity, allows us to perform actions when a game object enters or exits the sphere collider. Specifically, we'll use onTriggerEnter to add new target to our list and onTriggerExit to remove them. Now, how do we determine if the game object that collided with our sphere collider is indeed a target? For this, we can use the getComponent method and check if the object has a target component. If it does, we add it to the list. Here's how we can do that. Let's make a new variable called newTarget of type target equals other.getComponent target inside the onTrigger method. Then we can simply say if new target is not null, we use the method we created earlier called addTarget and we pass in the new target. Awesome. Now we can do almost the same thing for the onTriggerExit method, but simply switch the addTarget with the remove target. Remember, the process of identifying targets and managing them in a list is crucial for building the combat mechanics of our game. We'll be building upon this as we progress. Stay tuned. In your state machine folder, let's create a new state called PlayerTargetingState. Begin by opening the script and removing the start and update methods. Then, make the PlayerTargetingState a child of the PlayerBaseState. By pressing Ctrl and period keys over PlayerBaseState, you can implement the abstract class. Repeat the process to add the constructor, and as always, remove the exceptions from within the generated methods. Moving on, let's head back into Unity to set up our input actions. We'll create a target action. To do this, navigate to player inputs and add a new action named target. In many games, the tab key is commonly used for target locking, making it a fitting choice for our game as well. Therefore, bind the tab key to this action and save your changes. Next, within our input handler script, you'll notice some squiggly lines. Hover over them and press Ctrl and period keys and generate the onTarget method. This method will be called every time we press the tab button. Now, let's make this more dynamic by creating two new events within our input handler class, triggering them every time the tab key is pressed. Let's define these events as public event action target lock and public event action target unlock. So why do we need these two events? The first time we press the tab key, we want to enter the player targeting state, which is the action triggered by the target lock event. When we press tab again, we want to exit the player targeting state, an action which will be triggered by the target unlock event. To track these actions, we will need a new variable named isTargeting. This will be a private boolean variable initially set to false. In our onTarget method, let's first check if context.phase equals with input action phase that performed. If it is, we then check if the player is already targeting by evaluating if is targeting. If the player is indeed targeting, we call the target unlock that invoke and set is targeting to false. If the player is not targeting, we invoke the target lock that invoke event and set is targeting to true. This structure will allow us to seamlessly switch between targeting and non-targeting states as the player interacts with the game. Stay tuned as we continue to build this out. Next, we'll be setting our PlayerStateMachine to start responding to these events. At the top of the file, make sure to add the using system, as it's necessary for utilizing the event system. We're now going to bind our two events to two separate methods. Let's do this in our staff method. Input handler target lock plus equals handle target lock and input handler target unlock plus equals handle target unlock. Now, we do not have those two methods yet, so let's implement them. First, let's implement the handle target lock. It will be private void handle target lock, and inside it, we need to change the state to targeting state. So change state, new player targeting state, and we pass in this object. And the second method, private void handle target unlock, and inside it, we change the state to player idle state. So just copy the line above and just change the state to player idle state. What these methods do is they switch the player state between targeting and idle depending on whether the target lock or target unlock events are triggered. Now, let's dive into our player targeting state script and add a debug.log entering targeting state statement. This will help us verify if we are correctly entering the state. And similarly, on exit method, let's add a debug.log exiting targeting state statement to confirm that we're exiting the state as intended. Now comes the fun part. Let's run our first test. You'll notice that while you're in the targeting state, you won't be able to move. This is because we have yet to implement any form of movement, but don't worry, that's coming up in our next video. Excellent work! We've made substantial progress so far. In our next video, we'll tie all these basic components together to create a unified targeting system. We'll cover how to select the target and make our camera focus on the chosen target. Before we wrap up, let's recap what we've learned today. We've laid out the foundational pieces of our game targeting system, created the essential components, and prepared the necessary input actions. We also looked at how events can be used to drive transitions between the different player states. We're setting the stage for an engaging player experience, and I can't wait to continue this journey with you in the next video. Thanks for tuning in. Don't forget to hit the like button if you found this tutorial helpful, and subscribe to our channel to stay updated on our future videos. If you have any questions, feel free to drop them in the comment section below, and I'll do my best to respond. Until next time, keep learning and happy coding.